Afternoon, this is Kevin with Map Practical. So we're working on final projects. We're doing an Atlas of Conservation Cartography in the Advanced Cartographic Design course. And so students are just choosing a park somewhere in the world and going to make a nice little map of it. So a lot of folks are kind of struggling to set up their project and start their map. So I just wanted to cover that real fast. So here we go. We're going to explore protected areas. I know of a park in Senegal, Colo, that I've worked on, and we can check and see if we can find that. So there we go, Neocolocoba. You just find your park and then download, say, like a shapefile of the actual park. So I've already done that. You guys don't need to watch me download the shapefiles. So I've got that in my raw data folder. And then the next thing you need is a nice set of DEMs so you can generate a shader relief. So the best world coverage, global coverage of DEMs at the highest resolution are these 30-meter SRTMs. Maybe your park has better coverage, like a 10-meter DEM, or if you're lucky, some LiDAR. But in general, this is the best you can get. This site requires a NASA Earth Data login. So if you don't have one of those, you just click here and go to Earth Data and create a login and an account. And you can download the same data from here. It's just not super intuitive. So I do it through this site. So you zoom in down to where we are in Senegal for our park. And because I've worked here, I've looked at this a lot, and so I kind of know where the park is. And there it is right there. That's the shape of the park. So it would be these 4 DEMs. So you would just click on download DEM. It'll give you a zip file, and you get the other one. And almost without fail, everybody's DEMs have some match lines. So your park always falls in between at least 2, if you're unlucky, maybe 4. But we have the skills to take care of that. So go ahead and do that. And then, of course, you'll need some vector data as well. And hopefully you can find a nice source of vector data for your country or your park specifically if you wrote the rangers, and see if they have any GIS data for you. But a nice place to start if you have nothing is Diva GIS, and just go to this free spatial data and then the country level data. And then you can go to the country that you're interested in. In our case, it's Senegal. So there it is. And then underneath the subject, they have all these different things, and I just downloaded them all. So my administrative areas, my inland water, roads, railroads, elevations. You can check that elevation data and see if it's of a higher resolution, but I doubt it. Okay, so I've downloaded all of those, and then I start up our catalog. And I've already gone in and I've made a folder for my particular project, a raw data folder where I put all the zips, and then I unzipped all of my data. Why we're here is just to check things out and see if it's what we were hoping for. So I preview it. So there's the shape of my park. Very good. Let me go ahead and look at the properties on that one. It's in WGS84. That's good. And then here are my DEMs. So we can take a look at, there's one of the DEMs. And let's take a look at its properties. And scroll down here and see that it's also in WGS84. Super. So we'll set up all of our base data in WGS84, and then we'll project through the display projection in ArcMap. For my project though, I'm going to work in a geodatabase. So I'm going to go New, File Geodatabase. Always name them. Project. There we go. So there's a geodatabase, and then I'm going to make a feature data set inside of it. So New, Feature Data Set, and this will just be my park data, or it's actually my park vectors, right? Because you can't put rasters in there. And then next, and we'll just go with WGS84 and use the rest of the defaults, finish that, and there we go. So when I was looking at the DEMs, what I failed to check out is, under the properties, is I want to see what its pixel type and pixel depth are, because that's going to be important in the next step. So in this case, it's a signed integer as 16-bit, so 16-bit signed integer. Great. Now I'm going to go ahead and just right-click on my folder, but not in my raw data folder, in my master project folder. Oh, no, excuse me. I need to go to the geodatabase and then go down to New, and then a raster data set. I'm not going to create a mosaic or a raster catalog. I'm going to go with a blank raster data set. I'm going to name this, and this is going to be my Neocolo DEM. And what we're going to do here is get rid of any of those match lines. And this one needs to be a 16-bit signed, and that's what we needed. We don't need to mess with the cell size. That'll be brought in by the DEMs. Spatial reference as well, and because it is a DEM, it's just going to be one band. Say OK, and that was fast. And then I just right click on this blank DEM that we created and say load data, and that brings up the Mosaic tool. I've used multiple different workflows. This one seems to always work the best for me. Now I just need to load in those 4 DEMs. So we'll just grab those, drag and drop them right over. And there we go. Very good. And then we'll go with all of the defaults, and we'll just let that rip. And it's going to mosaic those DEMs together. And then we won't have the problem of unsightly match lines when we're trying to generate our shaded relief. And there it is, complete. So let's take a look. So there, and then we'll preview it. So there we go. So now we have those 4 DEMs. Now that's just an artifact of the mosaicing process, and it disappears depending which zoom level you get to. See, it's gone there. But I never like working with it. So the way I found to fix that is to right click, go to properties again on that DEM. And then if we go down to pyramids, right there, we're going to build pyramids, and I'm going to tell it to do a bilinear interp with no compression, and let that run, and that should get rid of that, that artifact in the middle of it. So enclose that, and say OK to that, and then re-preview it, and there we go. So now it's gone. Super. So let's start up an ArcMap doc. Now our atlas is going to be in landscape format, 8.5 by 11, just to make it easy. So that means we can set up our page and figure out our scale and everything in ArcMap really quick and easily. So here we go. We're just going to do my templates, and then I'm going to set my geodatabase that I just created as my project default geodatabase. That'll make life easy. We'll say OK. And then I usually go under File, Map Document Properties, and tell it to store the relative path names. Super. And then we'll go ahead and go inside of our geodatabase and add that DEM. And there it is. And it should have come in WGS84, and that's just fine. Now, if we wanted to set up our page, we would just go to Page Layout. There we go. And let's go ahead and change this guy to File, Page and Print Setup. And we're going to go with Landscape. Perfect. And zoom out a little bit. I'm going to set some guides at 1/2. These are 1/2-inch guides, 10.5. 8, and at a 1/2 inch there, and then stretch out our data frame to snap into those guides. Go to full page here, zoom to whole page. Super. And then I'm going to add one more piece of data. I'm going to go into my raw data, and we'll use the feature data set here in a second, but I'm going to take a look. So when I unzip this from the World Protected Areas database, it was double zip, so you just have to zip one thing and then unzip the shapefile. So we'll add that just to make sure. Okay, super. So we got a DEM with full coverage of our park. I'll go ahead and just kind of zoom to layer on that one. And you know, our layout is probably something close to that. I don't like to have these, you know, kind of non-round scale numbers, so I'll just do a fixed zoom in. 1 to 600,000, the park fits perfectly on this 8.5 by 11 page. Be a good time to save. So, and we'll make sure we're saving that in our folder. And this is going to be my Neocolo map. Save, excellent. All right, so I'm going to turn off the park boundary for a second. Actually, first I'm going to change its symbology so we can see the DEM underneath it. There we go, and then I will turn it off. And now we need to just run some Hillshade tools. I always leave my DEMs in their raw format as the way that they come from the download before I reproject or anything, so that my Hillshade tools work well. Now, for the advanced class, I've shown the students how to use a Swiss Hillshade model and a multi-directional light model, but I'm just going to do a simple one just to see if it's looking nice. So we'll go to Search, and then the tool we're looking for, of course, is just the Hillshade tool. And there we go. We'll grab that, and we'll put our Neocolo DEM in there. And we'll go with the defaults as far as the azimuth and the altitude, but the z-factor, because this is in WGS84, although our elevation is in meters, you will definitely have to set a z-factor. And the kind of constant that works the best, I think, is 0.12340 and a 3. And that should give us a decent looking Hillshade. Let's see what we get. While that runs, I'll take a sip of water. Cool. So there it is. And then we'll do all of our normal things. So obviously it belongs below the original DEM. I'll turn that DEM off for a second. I'll go inside of here and change this to bilinear interpolation under symbology. I'll probably want to go to properties, to color, and instead of white to black, I'll go like white to 30% gray. Say okay and okay. All right, not too bad. There's not a lot of elevation in this park, but that's all right. And then our main DEM, I'm going to go ahead and just give it a color ramp. And I already have one set up for Neocolo. Let's see if I can find it. There you go, Neocolo 22. And then I'll go to also the symbology tab and resample it to bilinear. Percent clip, maybe if I apply a gamma stretch, let's see how it looks. That's not too bad. Sometimes I'll go with standard deviations and see how that goes. That works as well. Forgot to give it some transparency though. Let's give it some, like say 65%. And there we go. So if we zoom in, you'll see that we've got a decent hypsometric tint. And it's, pretty basic because it only has 2 layers. If you had, a Swiss Hillshade with an aerial perspective and a filter, you threw an MDOW on there, maybe some land cover, you could definitely break it up and give it some texture. So, and now we can add some of the vectors that we downloaded. First thing I can do though is that I know that this park boundary is correct. So I'm going to go ahead and just do data, export data, and now is when I'll put it in my geodatabase. So let's go to our geodatabase into our featured data set, and this will be park border. No spaces. If you're going to leave spaces, you want to go with an underscore like that. Super, and then say okay. Yes, I want to add that one, and there it is again. So now we can get rid of that raw data. We'll do the same thing as far as the styling goes. And let's add some other data to it. So I'll go data, and I'm going to go up in my raw data. And let's see, I've got roads in Senegal. Let's see if those roads show up in my park. And they do. Great. And then what about if I were to add, say, the water? So we'll add the lines and see if the rivers show up. All right, so there they are. I'm going to go ahead and pull those down below our border. But these things are going to be bigger than our entire map, right? So it's the whole country. So it's extra data that we might not need to actually have. So if I go back to the data view here, you can see, yeah, these roads go out and about much further than my DEM space. Now I could create a box just with my drawing tool. I could create a square like this, knowing that it's going to cover, and then from the drawing drop down, say convert graphic to features, and that does work. You can only do that in the data view inside of ArcMap. But there's another cool tool that I can let you guys know about, which actually works pretty good. And let's do that. It's under search, and that's raster domain. And what that's going to do for us is allow us to create a polygon that is the exact shape of this raster of the DEM. So my input raster, of course, is my original DEM. It doesn't want to do the drag and drop. Well, then we'll just do it that way. And then it's going to go, let's do this, we'll put it inside our feature data set. And we'll call this our clip box. Great. And then you got to tell this thing to be a polygon, not just a line. And we'll say OK. And this just finds the exact perimeter of that DEM and gives it to us like that. So that clip box is what we can use to clip all of our data as we're putting it in there. So if we went back to our layout view and then maybe zoomed a layer on our park and then go up one to that 1 to 600,000, that's pretty good. But now I'm going to take my roads and I'm going to clip them so that as I'm trying to work with my roads, I'm not dealing with a bunch of extra data. So we'll do the clip analysis right there, and the input feature will be our roads, and the clip feature is that clip box. We'll make sure it's going in the right place, and we'll call this roads. Say save, super, okay, let that rip. Nice. So now we have a nice clean set of roads. We can get rid of the other roads because they're just in the raw data folder, and we'll do the same thing for the water, for the rivers. And that's going to be these water lines, and clip box is our clip. And put that in here and call it rivers. And let that rip. Great. So now we've got our rivers. We'll go ahead and remove our old one and then make those a river color. That makes sense. There we go. All right, so now our data is just out to the extent of the raster DEM. So we've already got a pretty good start. It's always a good idea to save. Of course, though, we're working in unprojected space now. So now would be a good time to project it. So I'm going to go ahead and take a look at my coordinate system tab under my properties for my data frame. And it's in WGS84. I'm going to go down to projected coordinate systems. Let's look at continental systems, Africa, and how about like a nice Albers equal area conic. We'll see how that looks. There we go. And we don't know where we're at as far as the central meridian, but I'm guessing that the central meridian for the whole continent is over in the center of the continent, not on the west coast where Senegal is. So I'm just going to hover over this, and then what you see down in the bottom here is where our latitude is. So it looks like -13. So I'm going to do a custom central meridian. So I'm going to right click on this guy and say copy modify. And the central meridian is at 25, so we need to take that over to -13, and we'll put a mod on the name up here. Say OK and OK, and we'll get a little bit of a twist, and there we go. So now we're pretty set up. We'll save again, and I can tell that I'm going to need, some more features. I'm going to need to find my villages. I'm going to need to find probably some international borders, because I can tell that there's data that is not being shown that's outside of the park. Now I can go looking for roads for Guinea, the country to the south, or I could just turn on one of the streaming base maps and hand digitize them here in ARC. But first things first, we'll probably want to turn off our all of our vectors and take a look at our relief. And now I would start working this guy up. And so there was a layer inside my raw data that was supposed to be land cover. Let's see what it was. Yeah, this is mask cover. And I know that the VRT worked. Let's see how that one comes in. So it doesn't look great. It's super pixelated, but we could still maybe use it to break up our relief. So what if I went in here, and of course I'm going to do bilinear data, and since this is a very mountainous, or not really as mountainous, but jungly area, we're going to go with some kind of a green ramp, like that one, and let's see how that looks if we apply that. So it's not great, but it's only going to be one layer in a big stack. We'll do a little gamma stretch, and then under display, I'm going to make this thing super transparent, like say 80%. Let's see how it looks. All right, could probably even go a little bit more, but if I tuck it under the other one, see, so it just breaks it up just a little bit, right? The other thing I could do, if I didn't have any other land cover, I couldn't find anything, is I can add a streaming base map of satellite imagery. You always have to be careful with satellite imagery, otherwise it just looks like an image with labels on it. So I never have that very high in the transparency. I want to make it really, really kind of subtle as far as the satellite imagery goes. So here we go. That's our satellite imagery, and we might want that in our layer stack, but we don't want this layer credit right there. And the way to get rid of that is to go under your insert, dynamic text, and then service layer credits, and then it puts them in a box that you can drag off of your page, and then they won't show up on your exports. And so now let's make this guy really transparent as well, like 85 or so. See how it looks. Maybe you could be a little bit less. Let's try 80. There we go. So we take, and then we turn that back on, and see we've got a little bit of a different look. So when we turn that on and off, it changes things up a little bit. Might even play with different transparencies. But in reality, we're probably going to make all of these non-transparent, and we're going to export them out as their own individual layers that then we're going to bring into Photoshop and use all those great blending tools and transparency tools inside of Photoshop. So to do that, we would just do multiple exports of our rasters. So we might start by turning everything off. So turn all layers off, start at your very bottom layer. So there's our first hillshade, and if you had a Swiss hillshade with a filter and an aerial perspective, you do each one of those individually. So you just turn one on and go to your file, export map. and then export this as your Hillshade. Oops. And make sure it's in the right folder. So like home here, there we go. And I might even make a new folder called like my relief blend, and then a 300 DPI TIFF would work. And then once I'm done with that export, I'd turn this one off, turn this one on, but then I'd go back and make sure there was no transparency on it and export that out. So just different layers that then you can use for your blend inside of Photoshop. And then once it's all done, you would then go through and start turning on all of your vectors, working on getting labels and so forth set up, and then do one export of all your vectors, or you do export map, and instead of a TIFF, then this one is going to become a .ai. 700 DPI is usually what I go with that, so that the vectors aren't snapped to a grid that's of too low resolution. And then you will have all of your vectors ready to go into Illustrator. You can do a relief blend in Photoshop, add it as the base layer, and start styling your map out with nice labels and nice symbology. All right, so that's how I would start your final project. If you have any questions, please leave them in the comments. Thanks for watching, and we'll see you next time.